All right, so now we're going to talk about proportionality theorems. And these theorems have their foundations rooted in similar triangles, but they don't actually use the similar triangles, which is kind of odd. So it makes enough sense to talk about them now. The point behind this, you should be able to use what's called the triangle proportionality theorem to find the length of a segment. And you should also be able to use these triangle proportionality theorems to solve real-world problems. Okay. So what are these theorems? The triangle proportionality theorem basically says that in a triangle, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Okay. Now, what does that mean? That means that if we draw some segment TU in the triangle so that it's parallel to QS, then it will divide these two sides up proportionally. So if TU is parallel to QS, then if I write a ratio comparing these two parts of this side, it has to be equal to the ratio comparing the lengths of these two parts of this side. Right? So, if TU and QS are parallel, then the ratio of RT to QT would have to be equal to the ratio of RU to US. Okay? Now, you can definitely go the other way. We know that with our proportion properties, we can flip both of these ratios over, and the proportion would still be true. So we could go QT to TR and SU to UR, but the theorem, but either way, it's the same thing. So that's what that theorem says, right? Now, there's a converse to that proportionality theorem that says that if a line divides two sides of a triangle proportionally, then it's parallel to the third side. So the original theorem talks about knowing the two lines are parallel first, and then we know that the sides are divided proportionally. The converse says, well, we can check to see if the sides are divided proportionally, and if they are, then that means that these two segments, TU and QS, are going to have to be parallel. So if you want to make sure that two segments are parallel, this might be one way to do it. Okay? The converse, I mean. All right, let's put it to use. In this diagram, QS and RS are parallel. Now, that doesn't make any sense. So we're going to change this a little bit. In the diagram, QS and UT are parallel, right? And if RS is 4 and ST is 6 and QU is 9, we can find the length of RQ, right? From the triangle proportionality theorem, if we know that these two guys are going to be parallel, if we know that these two guys are parallel, then I can write a ratio of this guy to this guy, and it's going to have to be equal to the ratio of this guy to this guy. So QR, we don't know, so let that be X, to 9 is going to have to be equal to 4 to 6. And we can cross multiply and solve. We get 6x equals 36, and so x is 6. So the length of QR is going to be 6. Okay? Pretty straightforward. Now, again, because of our proportion properties, there are a lot of different ways to write those two ratios and still get 6 as our correct answer. You pick a pattern for your first ratio, and as long as your second ratio follows the same type of pattern, you're going to be in pretty good shape. And we can discuss this more when we go through your homework. Okay? All right, real-world problem here, right? A shoe rack. On the shoe rack shown here, the length of AB is 33 centimeters. The length of BC is 27 centimeters. The length of CD is 44 centimeters, and the length of DE is 25. So explain why we know for sure that this gray shelf is not parallel to the floor. Okay, so AB is 33, BC is 27, Okay, CD is 44 and DE is 25. Now, if you want to redraw that, you certainly can. You can maybe redraw it and make it look something like this, and then label, but I don't think this picture is easy enough to label that we can kind of see what's going on. Now, we have to check the proportions, these ratios, right? I should be able to compare 27 to 33, and that should be equal to comparing 44 to 25. If that's true, then the gray shelf would be parallel. If it's not, then the gray shelf is not parallel. Well, when we cross multiply, we see 27 times 25 is 675. 33 times 25 is 825. These are not equal. So that means that this proportion is not true, which is why the gray shelf is not parallel to the floor. If it were, that proportion would be true. Okay? It's using the converse of that triangle proportionality theorem. Okay? All right. A couple more theorems. If three parallel lines intersect two transversals, then they divide the transversals proportionally. Right? We've talked about transversals before. Transversals are just any line that intersects two or more lines at different points. So line L and line M would be your transversals. Now, if three parallel lines intersect those two transversals, then it's going to divide the transversals up proportionally. For example, it creates these pieces, line L and line M, being intersected by line UV, line WX, line YZ, or line RS and T, divides up segments UW, WY, VX, and XZ. So if we were to compare the length of UW to VX, it would be equal to comparing the length, if we were to compare the length of UW to WY, it would be equal to the ratio of VX to XZ. So if you go down the transversal, those ratios should be equal to each other. Now, again, proportions. We can set these up a lot of different ways and get what we need out of it, okay? So if you see the ratios a little differently, it's not necessarily a wrong thing. Something that we'll have to, again, explore as we go over our homework, okay? All right. And last but not least, there's this opposite side theorem, right? If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Okay? Now, what does that mean? That means that if ray CD here is an angle bisector, which means that these two angles would have to be congruent. Okay, and I'm not sure you can see this proportion from the trial advertisement there, so I'll move it. But if that's true, if CD bisects angle C, then it hits the opposite side so that the pieces of these opposite sides are proportional with the sides that they're attached to. Okay? In other words, if I compare the length of AD to AC, it would be equal to comparing the lengths of DB to BC. What would also be true? Okay? If you have that, what would also be true, another way to look at this, is that if you compare the length of AD to DB, if you compared the lengths of the two segments that were created by the angle bisector, that would have to be equal to the length of CA to CB. So again, a couple of different ways to approach this particular theorem and how to set up a proportion to solve what you're looking for, solve for what you're looking for. Okay? All right, let's try them out. This first example. In the diagram, angle 1, angle 2, and angle 3 are all congruent. Okay? And GF is 120 yards, DE is 150 yards, and CD is 300 yards. Find the distance between Main Street and South Street. So Main Street being here, South Street being here, the distance we're looking for is HF, right? We're looking for HF and not CE. Remember, distance is always at a perpendicular. You don't go to the doctor and lean to one side and ask them to take your height, right? Plus, if I want to know the distance from a point to a line, I want to go straight at that line. HF is straight at the two lines where CE is not. So we've got to find HF. HF is that distance. Okay? Well, here's what we know. We know that this angle here, angle 3, is congruent to angle 2. And if you trace them, you get that F. Remember your F's? Those are your corresponding angles. And because those corresponding angles are congruent, that means that these two lines, 2nd Street and South Main, are parallel. Now, at the same time, angle 2 and angle 1 are congruent, which means that, and since they're corresponding angles and congruent, that means 2nd Street and Main Street are parallel. And by the transitive property of parallel lines, obviously Main Street and South Main are going to be parallel, right? So we have 3 parallel lines that are intersecting these two transversals. And so from our previous theorem, we know that the pieces of the transversals are going to be proportional, right? Which means that if I write a ratio comparing 150 to 300, which is the distance from, which is DE to CD, then it would have to be equal to comparing 120 to this piece here, GH, right? So GH is going to be X. Now you can cross multiply, and you get 150X, which is equal to 3,600. Okay? Divide both sides by 150. I'm sorry, 36,000, not 3,600. But divide 36,000 by 150, and we get 240. Right? So, X is 240. But we want to know the length of HF. So we got to do 240 plus 120, and HF is going to be 360. Not degrees, 360 yards. Okay? Piece of cake. Right? Just writing a proportion with those pieces of the transversal. All right? All right. Another example. In this diagram, angle QPR and angle RPS are both congruent to each other. Use the given side lengths to find the length of RS. We're looking for RS. Okay? All right. Well, here's the thing. Because QPR and RPS are congruent, that means that PR is an angle bisector. That means that PR is going to cut the opposite side by that theorem that we just talked about. It's going to cut this opposite side, QS, into pieces that are proportional with the other two sides. In other words, the ratio of QR to RS is going to be equal to the ratio of PQ to PS. Now let's fill in what you know. Do you know QR? No. QR, let it be, I don't know, X. Okay, well, we already have our X is RS, so can't do that. How about let it be Y? RS is X. PQ is 7, and PS is 13. Now, hang on a minute. I've got two variables in this proportion, so I'm not going to be able to solve it. Is there another way we can write QR? Well, this says that the whole length of the side QS is 15. If RS is X, how would you find QR? Well, we would have to take right, by segment addition property, QR plus RS would have to be equal to QS, right? We'll plug this in. QS is 15, RS is X, QR is just QR, right? Now we're going to have to subtract X from both sides to get QR by itself. So QR is going to be 15 minus X. So we can actually let QR, which is this guy over here, be 15 minus X. And now we've got a proportion that has one variable in it, and we can solve that, okay? Now we're going to cross multiply. We get 7x equals, make sure you distribute that 13, right? So 13 times 15 being 195 minus 13x, right? So add 13x to both sides, you get 20x equals 195. Divide both sides by 20, and you get 9.75. Okay? And RS was X, so this is what we were looking for. Okay? So there you go. Use of those two theorems. That's all I got to show you, right? So you have homework out in Canvas. Go ahead and bring that up, start working on it, and we'll talk about it next class.